the mountain, and the height of the mountain is 321 meters, and he looked to the horizon, and that made an angle of 0.567. What is the radius of the Earth? Okay. Okay, let's have a look here. So if I draw the picture, whoa, this here is or, and this here is H, and this here is or, and that's a straight line, and that curves, and that's a straight line, and this angle here is alpha. And if that's alpha, that's 90 minus alpha, which I'll just call it beta. This we're told is 90, so this must be alpha. So, what else do we know? We can say cos alpha equals or over or plus h. So or plus h cos alpha equals or. So or cos alpha plus h cos alpha equals or. So h cos alpha equals or minus or cos alpha, which equals or 1 minus cos alpha h cos alpha, they're all alphas. So I finish with or equals h cos alpha over 1 minus cos alpha, which I guess my answer at the back is wrong. This will be 321 cos 0.567 over 1 minus cos 0.567. What is that? Yeah. Yeah, I know, it's terrible. It's terrible, isn't it? It's my alphas, they look ugly. Alpha, 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 alpha. Alpha. Alpha, alpha. Zero 0.567. 0.567. Is that any better? No? Any better? Yeah. Okay, what was the answer here? 6? Yeah. Now it said two significant figures, so that's 6600000. 6,600 kilometers. What was my answer at the back?
6,300.
Okay. What's next now? Six? Continue. All of them? Okay. We'll do our best. Right. Can I go on to 6 now? Yeah, 6? Okay. Ship A is 40 kilometers east of ship B. So there's B, there's A. That's 40 kilometers. Oh, and also north of ship, and 30 kilometers north of ship B. Huh? Did I make a typing mistake here? Ship A is 40 kilometers east of ship B, and also 30 kilometers north of ship B. Yeah, so it should be up here actually. 30 kilometers. So not here. Okay. Ship B is heading northeast. How far has ship B travelled when A and B are nearest to each other? Okay, so what's happening here is B is heading at 45 degrees. So let me just try and draw that. 45 degrees, I'll just draw it like this. So this is 45. So they're nearest when B makes it here. When this distance, this angle here is 90. That's what I want in this question. I want this distance here. Now, the easiest way to do that, I think, would be to make a triangle here. That's 40, and that's 30, and that's 90. So what's this? 50. And you can actually also know this angle as well. This smaller angle. The smaller angle is tan inverse 30 over 40. What's that now? 56 or something? Tan inverse 30 over 40 in degrees, please. Okay, let's see. 36.87. So if we know the big angle is 45 and we know the small angle is 36, then we can know this angle here in the middle. It will be 45 minus that. So that's 8.13 degrees. .13 degrees. Now, if you look at this triangle, you know here to here is 50, and you want D, so which should I use? Sine, cos, or tan? Sine. 8.13 equals D over 50. So we have our first answer. D is 50 sine 8.13. So that is, you have the answer? 7.07, thank you. 7.07 kilometers. Okay, next. B. A. We know ship B can call ship A if they're 40 kilometers apart. How far has ship B travelled while the two ships are in radio range? Okay, can I scroll down? Yeah. So what's happening in this part of the story, this is still 30, this is still 40, this is still 50, but now the ship is heading to, yeah? Oh, the other way around, is it? Thanks. That's 40 and that's 30. Thank you. This is still 8.13. Yeah, and this distance here is still 7.07. Yeah. The ship is moving along here, and at some point it will be 40 kilometers away. So this here is 40. And it continues. And then it will be 40 again. And my question is, what's this distance? Well, if you look at it, this is 90. This you know. This you know. So we can get this side just using Pythagoras. So this distance is 2x. So 2x is the answer. And that would equal 2 square root 40 squared minus 7.07 squared, which equals 40 squared minus the answer lastly squared times 2. No, something went wrong, that's not right. 2 square root 40 squared minus 7.07 squared. 78.74 kilometers. Yep. Can I do the next part? C? C. So in this part, what was this, 40 or 30? I forget. Is this 40 or 30? 40? 30 and 50. And the ship is now heading this way. But the distance here, you're told, is now different. It's now 2.73. And we want to know this angle. Well, let's get this angle. We'll call it theta. Let's see. Sine theta is 2.73 over 50. Yeah? So theta is going to be sine inverse 2.73 over 50. 3.13 degrees. So the answer is it must sail at 48.13 degrees or more. Because if it's less than this, it's a problem. It's smaller than what we're allowed. But it's okay to be bigger than this. It'll just make a bigger distance. So it has to sail at more than 48.13 degrees. And then it will be a safe distance away. This is the safe distance in the question. Oh, sorry, no. You spotted my mistake. Not 48, because this is not 45. Yeah, thank you. What is it? 36.7. Was it?
About
36.87. Okay, let's recalculate this. Sorry. 36.87. 40. You know this word, Donna?
Yeah.
Good. What's next?
7 obviously.
Really? 7? But it's like what I did in class with the balloon. Remember the balloon?
Oh, yeah.
I can do it, it's no problem. Do you want me to do it? Yeah, you want me to do it. It's better if I do it, yeah? Okay. 7. A telephone pole has 2 wires attached to it. The first wire is 15 meters long, and the second one is 13 meters long. On the ground, what is the minimum distance between the pegs? So, the minimum distance between the pegs is if they're both on the same side. This one here is 15, this one here is 15, this one here is 13, this angle here is this angle here, come on, this angle here is 53.1 degrees, and this angle here is 67.4 degrees. And I want to know the distance between them. So I want this distance here. Okay. I know this angle. Right, so I can know this angle. And I can know this angle. Yeah? Let's get those. So this one is 180 minus 67.4. So that is 112.6 degrees. And on the top, it's 180 minus 53.1 minus the answer I just got. That is 14.3 on the top. Come on. 14.3. Just give it a... There we go. Right, so what rule should I use here if I want this distance on the ground? I'll call it D. I think the sine rule, yeah. I can say D over sine 14.3 equals 15 over sine 112.6. Take that up. Let's see what I get. Uh, 4.01 is what I got for the first part. In the second part, the only difference in the story is that the pegs are on opposite sides. So this is the distance D. This angle though is still 53.1, and this angle here is 67.4, and this is still 15, and this is 13. If I use the sine rule, I can say D over sine this angle on the top, which I'll get in a moment, equals 15 over sine, I'll say 15 over sine 67.4. Now this angle on the top will be 180 minus 53 minus 67. So let's just get that. That is 59.5. So I'll just cancel this and bring it up here. That's 0.4. Sine 59.5. Let's see what I get. 15 multiply sine 59.5 over sine 67.4. 14. 14 meters. Wonderful. Is it better?
Only one step.
Only one step?
Yeah.
Go on.
Both the two parts, I have both one step and I can solve it.
Tell me.
Okay. In the first part,
Yeah?
because there is 90 degrees in the right,
Yeah?
so we can only use cosine. 15 multiplied by 50.
Oh yeah, stop. I think the problem is that works, but it doesn't work if I do this.
Yeah.
Yeah. It only worked because I accidentally gave you more information. I should not have told you the 13 because you notice here you didn't need to know it was 13.
Oh.
Yeah. But you're right, you could have done it the two distances minus. Yeah. So I think I'll change this for next year and I'll delete the 13 meters from the question.
Okay.
Yeah. Because I don't want to make the questions too easy. Yeah. Okay. I suppose I'm doing 8 now. Okay, 8. Can I scroll down? Right. 3 superheroes. Let's see. We can have Ant-Man, Batman, and
Spider-Man.
who begins with C? Ah, Captain America. Yeah, okay. So we can have Ant-Man, Batman, and Captain America. They're trying to stop a helicopter flying away. The first one is 19 meters away from B. B is 17 from C. And each superhero has a 26-meter rope. And the helicopter is 24 meters above the ground. Okay, so this is hard to draw, but I'll try and draw it. This is the ground. Here's the helicopter. And it is 24 meters from the ground. And the 3 superheroes are standing around it like this. One is here with the rope. One is here with the rope. And one is here with the rope. And this distance from A to B is 19. And from B to C is 17. Oh. Ugly. Right. That's so ugly. This is the ground, so I'll draw this in green for grass. And there's one standing here, one behind here, and one here. And this is B, and this is C. Okay, it's very hard to draw in 3 dimensions, but what's happening is the helicopter is here like this, and you have the 3 ropes coming down from it. Yeah, do you understand? So the helicopter is here, and there's one rope, there's another rope, and there's another rope. Yeah? Right. So, what do we do? Let's see. Okay, I think what I'll do, if you can try and understand from my picture, I'll draw a triangle here on the ground and then going up. So this is the triangle, that has A in the corner. Now, we know this is 24. No, we don't. We know these are, how long are the ropes? 26.
Yes.
The ropes are 26. The height of the helicopter is 24. So we know that this is 24 and this is 26. So how big is this? This is Pythagoras 10 from Pythagoras. This is 10. Now we can do the same thing for B and we get the same answer. If we look at B, this is 26, this is 24, so this is also 10. And the same for C. Also 10 and 10. So that means this is a 10, this is a 10, and this is a 10. Yes? Yep. Now, what I do next is I now look at it from the top, straight down from the top. So, if I can look at the top, there's A, there's B, and there's C. Come on. And here's the middle. This distance is 10. This is 10, and this is 10. These are all 10. You know this here is 19. You know this is 17. Let's see. You know this is 10. You know this is 10. You know this is 10. Okay, I think we're starting to get enough information. What was I looking for? I want to know this side here. If I knew this angle, I'm finished. If I knew this angle and this angle, I can know this angle. But I can't know this angle because I can use cos rule. I'll call this angle alpha and this angle beta. So I can say 19 squared equals 10 squared plus 10 squared, plus or minus, I forget. A squared equals b squared plus c squared minus 2, 10, 10 cos alpha. Can I know alpha? Yes. And then can I know beta? Yeah, it's the same thing, isn't it? Except I just changed this cos beta, and the 19 is a 17. So let's get the alpha. Cos alpha, so cos inverse. Okay, what have I got on the top? I have 19 squared minus 10 squared minus 10 squared over minus 2 times 10 times 10. So my alpha is 143.6. Now let's get my beta. My beta is going to be 116.4. So now let's get my last angle, gamma. Gamma will be 60, yeah. 143.6 minus 116.4. 100. Right? So now, finally, I can say x squared equals 10 squared plus 10 squared minus twice 10, hang on, I'll make this neat, minus twice 10, 10 cos what? 100. Yeah, did you speak Chinese?
No.
No, okay. Oh, gamma! I thought you were speaking Chinese. You're just speaking Greek. Okay. 10 squared plus 10 squared minus twice 10, 10 cos 100. Square root answer. 15.3 to the nearest meter, 15. That was a hard one. I would be very impressed if anybody got this. Did anybody get this? No. Very hard. Okay, what's next? 9. Oh yes, yes. Did you get 9? Are you okay?
No, I'm not sure.
You're not okay?
I didn't try.
Ah.
Yes, I am okay. Is it really?
I'll tell you when they start getting more difficult than the exam. So in the exam, you should be able to do question 1 to 5. And 6. 6 was in an exam 1 year. It was in the exam the year I wrote it. Good news for you. Good news. I write hard exams. But this year, the other maths teacher is writing the exam. This is good news for you. Because I like to make my questions hard. Yes. 6 is the hardest one I've seen in the exam. I know because I'm the one who put it there. 7, 8, 9 and 10 are a little bit harder than what you might get in the exam. But they're still good practice because they're hard. Let's have a look now at 9. Nine is great. I love 9. Let's have a look at 9. A plane leaves point X heading east. So here's the plane and it's flying east. Another plane at the same time leaves Y at the same speed. Y is 20 degrees north of east. So up here at 20 degrees, let me draw it like here. Here's Y. Okay. And this plane is heading east. And this plane wants to meet the other plane that left X. So it heads along it heads along until it meets it. And my question is, what angle should the plane leave at? So we'll measure the angle this way. I'll just draw the line here. Basically I want to know what this angle is here, theta. Now this question seems a little bit difficult because we don't know this angle, right? So can we know this angle? No. We don't know this angle, we don't know this angle. Can we know this angle? No. Oh no, we can know this angle. This one is 20. Can we know this angle? No. Because we don't know this angle. So can we know this angle? No, because we don't know this angle.
Yes, yes.
Do we know any of the lengths? Any of the distances? Do we know this distance? No. Do we know this distance? No. Do we know this distance? No. So, what can we do? Well, I know one thing, and I wonder if someone can tell me why. I know that this distance is the same as this distance.
At the same time.
Yeah, and for another reason too. Not just because the same time.
No, not same.
They must be the same.
The same speed.
Yeah, because each plane travels the same time at the same speed. Think about this. If I have 2 cars, okay, the 2 cars leave at the same time and they travel at the same speed and they travel for the same time, then they must travel the same distance. So I know these 2 distances are the same, which means I know this angle must be 20. Because it's the special triangle. You know, the isosceles triangle where these are the sides. And if this is 20 and this is 20, then this one here, I drew this very badly. This one here is 140 then. Huh? Oh, and this here, yeah, is 140. Yeah. So we know all the angles. So that's it for number 9. Really, yeah. I told you it's my favorite. Very easy now. Next. Okay, can I do number 10? Number 10? What is the radius of the biggest circle that can be put into a triangle with sides 13, 14 and 15? Okay, so that's 13, that's 14 centimeters, and that's 15. Now, you might have to check some vocabulary, but I want to know the biggest circle which goes inside. That's a circle, believe it or not. The biggest circle. Now, I gave you the name of this circle. It's called the incenter. And what's special about this circle is the center is here, and these are all 90 degrees. Yeah, you might want to look that word up later, okay? Incenter. Right, let's try. Okay. Can I know this angle? Yes. Can I know this angle? Yes. Can I know this angle? Yes. What else can I know? I'm trying to get this. I need to draw more triangles, I think. More triangles will do it. Yes, more triangles will do it. Yeah. Okay. Here's a triangle. Here's a triangle. Here's a triangle. Also, the center splits these angles equally. Equal. Yeah. I mean, these two, it's in the middle. And this one is in the middle. And this one here is in the middle. Right, so if I can find this angle, if I divide it by 2, I get this angle. You got this one already for me? Maybe, I don't know, I have to calculate it. Let's call it alpha. Okay, 14 squared equals 13 squared plus 15 squared minus twice 13, 15 cos alpha. Okay, let's go back. There we go. This is 14. This is 13 and this is 15. Okay, so alpha is 89. That seems wrong, doesn't it? Oh, I forgot about the top. Sorry. 13, 15. 59. 59.5. 49. I know this angle. Wonderful. Okay, let's get the one up the top here. So on the top, what's the difference? It's going to be this now. 15 squared equals 13 squared plus 14 squared minus twice 13, 14 cos beta. Right, let's get this angle on the top now. What's different? This is 15 and this is, it's 13 and 14. No. Yes. Right? 67.38. Okay, what's the easiest way to get the last angle here?
180.
That's it. 180 minus 67.38 minus 59.49. 53.13 degrees. Okay, so I can know this angle. I can also know this angle. I can also know this angle. My goodness, this is a super hard question. Let me think a moment. Who made this question? Oh yeah, me. Let me think. Yeah. If I call this side here or, I could, and I call this X and I call this what? No, hang on. I don't know if this will work, if this way will work. Let me try. Tan 59.49 over 2 equals or over X. No, I don't like it. I don't like this way. Hold on, you should be helping me. We learn when the questions are difficult because we have to think hard about it. What else can I know here? Can I know this distance? Yes, actually. I can know this distance from the sine rule. I know this angle. I know. Yes, I need this angle. That's what I need. Let's call this theta. Theta equals 180 minus 59.49 over 2 minus 67.38 over 2. What's that, please? 180 minus 59.49 over 2 minus 67.38 over 2, 116.57. Okay, if I know this and this and I know this, I can know this. If I know this and this, I can know this. Good. Sine rule time. Sine 67.38 over 2 over h, I'll call this side h, equals sine 116.57 over 13. Right, let's get the h. Sine 67.38 divided by 2 times 13 divided by sine 116.57. 8.06. Now, finally, let's draw this triangle. This is 8.06. This is OR. This is 59.49 over 2. So I can know OR because now I can say sine 59.49 over 2 equals OR over 8.06. Four. OR is 4. Ah, that was hard. That was hard. Super hard question. Did anybody get it right? No. Don't worry, this is way too hard for the exam.
Peter, why are these angles the same in this?
It's because you might... I'll show you, hang on. It's part of the definition of what an incenter is. I mean, it's like that's the meaning of the incenter. There's do you know geometry? So geometry means like the rules in maths, you know, the rules that say things like this is the same as this. You did this in middle school. Yeah. That's one of the geometry rules about the incenter. That for a circle here, the center is where the angles are cut in half. That's for incenter. It means the middle of where the angles meet if they're in the middle. So if you cut these angles in half and draw them together, it'll make this circle called the incenter. Yeah. This here, and this here are 90 because this line is what's called a tangent to a circle. And you know maybe also from geometry, if you draw a line from here to here, this is 90. So it's difficult, but it's advanced, but it's too difficult for the exam, so you're not to worry about this. I just like to do this one because it's difficult and makes you think really hard. Yeah. But like I said, for the exam, I think it's good if you can do 1 to 5. That's for exam difficulty. Yeah. Hang on, let me think. Wait. The other maths teacher is writing the exam. I can tell you which question she likes. Because you know, we all have our favourite questions. Yeah. She's writing the maths exam. She likes to ask questions with the building. You see number 3? This is her favourite question, the building one. Or also the next one, the island. It's good for you because my favourite question to ask in the exam, if I write it, is, no, not this, is number 6. I told you it's good news for you. I told you it's good news. Okay, we'll finish there. I'll see you after lunch then.